Today we are going to learn about mastering API requests with Python's requests library. We'll explore the techniques for making, managing, and optimizing API requests effectively using Python's powerful requests library.
Welcome to our tutorial on mastering API requests using Python's requests library. In the world of software development, APIs, or application programming interfaces, are pivotal in allowing different software applications to communicate with each other. Python's requests library is a powerful tool that simplifies this interaction, making it easier to send HTTP requests and handle responses efficiently. Throughout this video, we will dive deep into how to use this library to perform various types of requests, handle responses, and ensure your API interactions are as effective as possible. By the end of this session, you will be well equipped to integrate APIs into your applications, automate tasks, and enhance your software development capabilities.
Before we can start making API requests, we need to ensure that the Python requests library is installed in our development environment. To begin, you should have Python installed on your machine. You can verify this by typing Python version in your command line. Next, install the requests library using pip, Python's package installer. Simply type pip install requests in your terminal. It's a good practice to use virtual environments in Python to manage dependencies for different projects. You can create a virtual environment by running Python mvend myaf and activate it with source myaf/bin/activate on Unix or myaf/scripts/activate on Windows. After installing the requests library, you can verify it by opening a Python shell and typing import requests. If no errors appear, you're all set to start making requests. Understanding how to set up and manage your environment is crucial for maintaining clean and efficient workflows.
GET requests are one of the most common types of HTTP requests. They are used to retrieve data from a server. With the requests library, making a GET request is straightforward. For instance, to fetch data from a public API, you can use request.get https://api.example.com/data. This returns a response object from which you can extract information. The response object contains several attributes, such as status_code, headers, and text. The status_code tells you if the request was successful, typically by returning a code 200. You can access the content of the response using response.text for text data or response.json for JSON data. It's crucial to handle different status codes appropriately, especially errors like 404, not found, or 500, internal server error. Understanding how to interpret and handle these responses is essential for building robust applications. POST requests are used to send data to a server to create or update resources. This is particularly useful in scenarios like submitting form data or uploading files. In Python's requests library, you can make a POST request with request.postURL, data equals key, value. If you're sending JSON data, it's more efficient to use JSON equals key, value instead of data. This automatically sets the content type to application/JSON. Once the request is sent, you can handle the server's response similarly to a GET request. It's crucial to ensure that sensitive data is sent securely. Using HTTPS instead of HTTP can encrypt the data in transit. Additionally, always validate the server's SSL certificate. Being mindful of these security considerations is vital for protecting data integrity and confidentiality. Headers and query parameters are integral to customizing API requests according to specific requirements. Headers are key-value pairs sent with requests to provide additional context, like content type or authentication tokens. In the request library, you can specify headers using the headers parameter, headers equals authorization, bearer token.query parameters are used to pass data in the URL of a GET request. You can include them in the request URL or use the params parameter, params equals key1, value1, key2, value2. These parameters are appended to the URL as a query string. Properly managing headers and parameters is crucial for ensuring API requests are authenticated and formatted as expected by the server. This not only helps in accessing secured endpoints but also in optimizing the data retrieval process. Error handling is essential for creating reliable applications that can handle unexpected situations gracefully. When working with APIs, you might encounter errors like network timeouts or server unavailability. Python's requests library provides a way to handle such errors using exceptions. For instance, you can use try and except blocks to catch exceptions like requests.exceptions.requestException. Implementing retry mechanisms is another strategy to enhance robustness. Libraries like Tenacity can help implement retries with exponential backoff, ensuring that the requests are retried after increasing time intervals. This is particularly useful for handling transient errors. Additionally, logging errors can provide insights into the frequency and nature of issues, aiding in debugging and improving application reliability. By effectively managing errors and implementing retries, you can ensure your application remains stable even in adverse conditions. JSON, or JavaScript Object Notation, is a lightweight data interchange format that's easy for humans to read and write, and for machines to parse and generate. It's widely used in API interactions. When working with JSON data in Python's requests library, you can easily parse JSON responses using the response.json method, which converts the JSON data to a Python dictionary. This allows you to access nested data structures using keys. When sending JSON data in a request, use the JSON parameter instead of data, which ensures the content type is set correctly. Understanding how to work with JSON is crucial for interacting with most modern APIs, as it's the preferred format for data exchange. Python's built-in JSON module offers additional functionalities like converting Python objects to JSON strings using json.dumps and parsing JSON strings with json.loads. Mastering these concepts will enable you to effectively manage JSON data in your applications.
Optimizing API requests is crucial for enhancing performance and ensuring efficient use of resources. One key aspect is minimizing latency. This can be achieved by reducing the data payload size and compressing data when possible. Efficient use of caching can also significantly improve response times. By caching responses locally, you can avoid repeated requests for the same data, reducing server load and latency. Managing API rate limits is another critical factor. Exceeding rate limits can lead to throttling or temporary bans. Implement strategies to track and adhere to these limits. Security is paramount when transmitting data. Always use HTTPS to encrypt data in transit. Additionally, consider implementing authentication mechanisms like OAuth 2 to secure API access. By following these best practices, you can optimize your API interactions, ensuring they are fast, efficient, and secure. As we conclude our tutorial on mastering API requests with Python's requests library, let's recap the key points we've covered. We've explored how to set up the requests library, make GET and POST requests, manage headers and query parameters, handle errors, and work with JSON data. These skills are invaluable for integrating various services and automating tasks in software development. Understanding and mastering API requests opens up numerous opportunities for creating powerful and efficient applications. I encourage you to practice these concepts regularly and explore further learning resources to deepen your understanding. Thank you for joining us, and happy coding!